Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. Thank you for your attention to me. First introduce, my name is Siswoyo. I'm a student of Faculty of Computer Science from Dian Nuswantoro University, Semarang. In this presentation, I will discuss about classification of lung disease based on Rontgen image using support vector machine and Gray-level Cochrane metric. Introduction. Lung disease or disorders are generally detected by conducting a clinical examination. In addition to clinical examination, lung disease can also be diagnosed by analyzing medical image. Medical image analysis focuses on the analysis, appearance, and enhancement of medical images obtained from various image modalities such as mammography, radiography, ultrasound, and computed tomography. Chest X-rays can be used to screen for various lung diseases such as pneumonia, and other lung disease. Radiation X-rays use small doses and are non-invasive, so they are preferred. In addition, it is also easy to obtain, especially in developing countries, and much more economical. Automatic analysis and classification of certain diseases on X-rays disease images can be used as a reliable alternative technology. Methodology. The dataset used in this study was obtained from the Sanson Hospital public dataset. The Sanson Hospital dataset of 662 can be downloaded via the link. The X-ray image obtained in the image used for training and testing. In the imaging system training stage, 70% of the total sample size of each dataset was selected at random. X-ray image from the Sanson Hospital dataset used for training and data amounted to 462 images. For the testing phase of the imaging system, 200 X-ray images were selected randomly. There is the flowchart of the proposed method. There, pre-processing with grayscale, histogram, equalization, contrast, limited adaptive histogram equalization, and median filter. Next stage, segmentation with active counter, and next stage, filter extraction with level Cochrane metric, and the next stage, classification with SVM. Results. In the segmentation process, the image is processed using the active counter method, which has previously been applied several methods of improving image quality with class, as shown in figure 5b. After finding the location of the lung, then masking is done, as shown in figure 5c. The lung object that has been selected is then stored for later feature extraction, as shown in figure 5d. Results continue. The research results that will be discussed are the result of training and testing data using the SVM. At this stage, the average value of the QLCM features will be classified according to the respective TLCM angles using the kernel method. The TLCM angles used are four directions, namely 0 degree, 45 degree, 90 degree, and 135 degree. Kernel functions that will be used in the analysis include linear, polynomial, radial, and radial basis function or RBF and Gaussian kernel. The results of the analysis of the calculation of classification accuracy are seen based on the calculation of accuracy, precision, and recall on each kernel function. Results continue. The result of the percentage calculation of accuracy from the trial implementation of SVM with its various kernel functions. Based on the picture, it can be seen that the accuracy value tends to be higher in the polynomial kernel with a direction of 135 degrees, while the value in the 0 degree direction tends to decrease or lower the accuracy value. The highest accuracy result of 71.3% is obtained by the polynomial kernel in the direction of 135 degrees. Results continue. The result of percentage calculation of sensitivity from the trial implementation of SVM with its various kernel functions. Based on the figure, it can be seen that the sensitivity values tends to be higher in the polynomial kernel in the direction of 135 degrees, while the values in the direction of 90 degrees, 45 degrees, and 0 degrees tend to decrease or lower the sensitivity value. The result of the highest sensitivity of 78.29% obtains a polynomial kernel in the direction of 135 degrees. Results continue. The result of the percentage of calculation of specificity from the trial implementation of SVM with its various kernel functions. Based on the feature, it can be seen that the specificity value tends to be higher for linear kernels in all directions, while the values for polynomial kernel for specificity values tend to be lower or lower than other kernels. The highest specificity result of 68.91% was obtained in the linear kernel with a direction of 90 degrees. Conclusion and future works. Based on the analysis of the result of TLCM feature extraction on lung radiograph, it can be used for the classification of normal and abnormal lungs. The characteristic of TLCM is to measure the level of randomness of pixel in the image. Utilization of feature extraction TLCM on lung X-ray image for lung disease classification can give the best result with an accuracy value of 71.13%, sensitivity 78.29%, and specificity of 69.27%, with a total of 660 training dataset at a distance of 1 pixel distance and in the GLCM direction of 135 degrees. This shows that the system that has been made can classify quality well. The image segmentation process using active counter has proven to be effective in finding the region of interest of lung image, but has to add the diameter of lung size manually, because the shape and size are different for each individual. Further research needs to add a method to change the dimension of the lung image automatically. Thank you. This is my presentation.